Hi folks, this is the first video on projectile motion. It's just an intro and definitions and explanation of what it's like to move like a projectile, and then we'll get into problems in future videos. Projectile is defined as any object that is in midair, and so projectile motion is the describing of motion of objects that are in midair. They've been launched somehow, whether they were let go, thrown into the air, fell off something, and they're just flying through the air. They're essentially falling. They are only influenced by gravity. That is not a true statement, but it is a true statement within AP Physics 1. We assume that the air has no effect on a projectile. In reality, any projectile that's moving through the air has to push the air out of its way, and that means that the air pushes back on the projectile and affects its acceleration. But we will only consider the effects due to gravity. So, the main idea here is that gravity causes downward acceleration, and because of that we can make three conclusions. The first conclusion is that a projectile has constant horizontal velocity. So its motion in the horizontal direction is constant velocity. Constant velocity arises because the acceleration in that direction is zero. So gravity is downward. And remember, we've been talking about separating our x and y motion, and so downward is in the y direction, and so there's no acceleration in the x direction. So constant horizontal velocity because gravity doesn't act in the horizontal direction. This means that we have one equation for motion for a projectile in the horizontal direction. Delta x equals Vx times t. The displacement in the horizontal direction is equal to the horizontal component of the velocity times time. More on that later. The other conclusion has to do with the fact that because gravity acts in the downward direction, there is constant vertical acceleration. And so the acceleration in the y direction is the acceleration due to gravity, negative g. And we can use 9.8 for g or 10. If you use 10, that's encouraged by the College Board. My answer keys will be a little bit off from yours when you're doing free fall problems. But it doesn't matter. Anyway, because of that constant vertical acceleration, we can write the kinematic equations a little bit differently. We can write them in terms of the y direction. So instead of delta x, we have delta y. That's the vertical displacement. And I'll just write out the rest of this equation and explain it. So the vertical displacement is equal to the initial component, the initial vertical component of the projectile's velocity times time, plus 1/2 times the acceleration in the y direction times time squared. Vx and Vy naught I'll explain in the next video. The other equations can then be written like this. Vy equals Vy naught plus Ayt. So the final vertical component of the velocity is equal to the initial vertical component of the velocity plus the vertical acceleration times time. And then now you've seen all the videos, all the equations, and all the variables. So all that's left is to write the final kinematics equation in terms of the y variables. So we have a lot more going on in the vertical direction because the acceleration is not zero, and so that motion is more complex. If we combine these two equations, the constant velocity in the x direction, the constant acceleration in the y direction, we see that there's a quadratic equation here. And so the final conclusion is that projectiles have a parabolic trajectory. So I'm just going to draw a parabola. All parabolas for projectiles are inverted. They're downward facing. I did a terrible job of drawing a parabola. It's not symmetrical, but it's close enough. So any projectile is going to trace out part or all of this shape. And what I'm going to do, we're going to imagine that this is the ground. I'm going to draw an object at various points. So I'm going to go for the beginning at the ground, the end when it hits the ground, the middle at the very top, and then I'm going to pick two locations in between. And so here's what we're going to do. Velocity is something that changes as the projectile flies. the actual velocity of a projectile is always tangent to the path that it's taking. The path that it's taking is called their trajectory. So this would be the initial velocity, and then every other velocity along the path is just going to get the variable v. And even when it hits the ground, the ball has to hit the ground with a velocity. And so, this is level ground. We don't have to have level ground be the beginning and end of our projectiles. Things can land higher or lower than they begin. But this would be like a generic path of a projectile. The velocity is constantly changing direction because even though the horizontal component is constant, the vertical component of that velocity is constantly changing. And so now I just want to look at the components. So this is just the path of the projectile that is because of the vertical acceleration. The projectile has a horizontal component to its velocity. And what we have said above is that it doesn't change. And so Vx is constant. Once the projectile is launched, then that velocity remains throughout the flight. I put a comma here, it says v comma vx, because this motion right here is horizontal. If you think about the path of a projectile, if you think about a parabola, the slope of the parabola at the top is 0. So at the top of a projectile's motion, all of the motion is horizontal and none of it is vertical. And we're going to see that again in a minute. So the horizontal component remains the same. However, the vertical component changes. So it starts at a maximum value and then it gets smaller. By the time you get here, it's not Vy naught anymore, you have a vertical velocity of 0. That's the top of its path. It's done moving up, and it's now starting to move down. And then on the way back down, Vy starts to get bigger and bigger. Okay, so Vy decreases until the top. Vy equals 0 at the top, and then Vy increases after the top. So now we're talking about a vector, so Vy naught would have its most positive value at the beginning, and then that value would get more and more negative. If we had a projectile that like rolled off a table, then the vertical component of the velocity would start at 0 and then get more negative. So Vy is always getting more negative. If a projectile is launched upwards, then it starts positive and then becomes more negative from there. So this is only just the shape of the trajectory, and it is due to the changes in the vertical component of the velocity, even though the horizontal component stays the same. So that's the end of this video, and we'll solve some problems in the next one.